This presentation provides information on how gates and circuits work together in electronic devices. The reason for which computers are capable of performing complex operation is due to the interconnection of logic gates. Logic gates are implemented by using transistors, diodes, relays, optics, and molecules, or even by several mechanical elements. Logic gates can also be considered as electronic circuits. A logic gate is a bit like a doorman or a bouncer who is allowed to let people into a nightclub only if they pass certain tests. There are quite a few different types of logic gates, the most common of which are listed here. Calculators, for example, can do all the things they need to using different combinations of logic gates. It's logic gates that control how the display works in a calculator and more logic gates that figure out the results of calculations. Each segment of a calculator's display is switched on and off by a series of logic gates that are connected together. Transistors have the capability to switch tiny electrical currents on and off or amplify them by transforming small electrical currents into much larger ones. Transistor switches can be put together to make a logic gate, which compares several input currents and gives a different output as a result. Logic gates let computers make very simple decisions using a mathematical technique called Boolean algebra. When working as an amplifier, it takes in a tiny electrical current at one end and produces a much bigger electrical current at the other. In other words, it serves as a current booster. When transistors work as switches, a tiny electrical current flowing through one part of a transistor can make a much bigger current flow through another part of it. In other words, the small current switches on the larger one. This is essentially how all computer chips work. Digital systems are said to be constructed by using logic gates. These gates are the AND, OR, NOT, NAND, NOR, XOR, and XNOR gates. The AND gate is an electronic circuit that gives a high output only if all inputs are high. The OR gate is an electronic circuit that gives a high output if one or more of its inputs are high. The NOT gate is an electronic circuit that produces an inverted version of the input as its output. This is also known as an inverter. A logic gate might sound horribly complex, but it's simply an electrical current with two inputs and an output. It receives two incoming electrical currents, compares them, and sends on a new outgoing electrical current depending on what it finds.